we will find the length of BC. If we have two sides of a right-angled triangle and we need to find the other, we may make use of Pythagoras' theorem. Now, as we can see, BC is what we need to find. BC is also in a right-angled triangle. And in this right-angled triangle, we have the other two sides are known. BC is what we are about to find, and we are making use of the other two sides of this right-angled triangle. We have the hypotenuse, and we need to find one of the shorter sides. We will subtract the square of the other short side from the square of the hypotenuse, and of course we take the square root of the entire result. But it is important to note that we have the hypotenuse because a common mistake that students make is that as soon as they are required to find one side of a right-angled triangle, they go ahead and add the square of the other two sides. We have the hypotenuse and we need one of the other shorter sides. Therefore, when we find the squares, we will subtract the square of one short side from the square of the hypotenuse. BC is therefore equal to the square root of the square of the hypotenuse, subtract the square of the other short side. The hypotenuse goes there, and we see the other short side is 8 meters. BC is therefore equal to the square of 10 is 100. The square of 8 is 64. 100 minus 64 is 36. We need to find the square root of 36, which we know to be a positive or a negative 6. The negative square root in this particular case is not applicable because we are talking about the length of one side of a triangle, which cannot be negative. Therefore, we need only to make use of the positive square root. In another twist to the solution of the problem, the most popular right-angled triangle has sides in the ratio 3 to 4 to 5. So we say that it is a 3, 4, 5 right-angled triangle. Students may immediately be able to figure out that the missing side is 6 centimeters. Students are familiar with this very popular right-angled triangle, the 3, 4, 5, and they can see that the ratio of the sides is 3 to 4 to 5. Then they can figure out the length of BC immediately. We are about to make a little demonstration as to how the student may be able to do that. The longest side that we have there is 10, and we are assuming that that 10 side is also 5 in the ratio. If that 10 side is 5 in the ratio, examining the hypotenuse, it appears as if the factor is 2. That is, the factor linking the actual sides of the triangle to the ratio of the sides of the popular right-angle triangle will appear to be 2. Because if we assume that the 10 meters represents the 5 side, then of course 5 2 is 10. Then we'll take another side. That fact is confirmed by the 4 side. So we have the 4 side, which we imagine will be 8 meters. That is, 4 in the ratio is represented by the 8 meter side. There's no difficulty seeing that 4 2s 8, and we already made a guess that the factor would have been 2 from the fact that the 5 side is 10. 5 2 is 10, And we are confirming that with the fore side, which is 8 centimeters. Therefore, we have no difficulty seeing that what we should do is take this 3 and multiply by 2 in order to find the length of the remaining side. We will proceed to this 3 side and 3 2's because the factor linking the ratio to the actual sides of the triangle is 2. 3 2 6. There's no difficulty. All of this process need not be recorded or documented. The student will be able to do all of these mentally and in a few seconds figure out that that missing side is 6 meters. The key to making use of a 3, 4, 5 right angled triangle, of course, the sides are in the ratio 3 to 4 to 5. The key in using that method is to ensure that the hypotenuse is the 5 side. If not, the problem may end in a disaster. Therefore, if we are using the 3, 4, 5 ratio to be analogous to the sides of the right angled triangle, then the longest side of the right angled triangle must match with the largest number in the ratio. If that is not the case, the result may be disastrous. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.